It's been a while now since I was on FTFE's and Ranty's channel talking about my observations from the end of the world. But then Ranty started to talk about something sinking or something. Let's see what he had to say about that thing.
One thing I would say is look into sinking. You know, if you don't understand what happens with sinking, Craig put a laser image out before where he's showing the laser through the fish tank. And what you see is the laser going, sinking downwards.
The thing is, Ranty, every single distortion would show up in a photo as distortions.
Well, you know,
there will be stretching and squeezing and distortions and boiling and everything that it would show in the photos. You can't have distortions without seeing it on the photos.
So apparently something is sinking because Ranty says it's sinking. So I guess it must be sinking. Well, let's hear what he said about what weather conditions you need to have for sinking.
What you said in the stream, that this was sinking or something.
Mm-hmm.
Yeah. What requirements do you have in the weather for sinking effect?
The same that you would need for looming.
That would be?
The light refracting to a denser medium.
Yeah, but refraction follows the curvature of the Earth, so...
only if you've got a curvature of the Earth.
Let me
just answer you. With the same parameters that you would need for looming on a globe, would be the same parameters that flat earthers would need for sinking on a flat plane. It's exactly the same. So the light would just travel from the less dense regions to the denser regions. On your model, that would skip it around the globe, so it would be loomed, and on a flat plane, it would just sink it. So as long as the light travels, which we know it does, from the less dense to the denser regions, then in both models, it's exactly that, you know, it works. It's just deciding which model is accurate. You know, is it sinking or is it looming? You know, that's what we've got to decide. The mathematics and the science behind it would be equally valid on both models, and it's just the same.
Except for one thing, that it bends towards the denser medium.
Yes, that's what I've just said.
So if the Earth was flat, it wouldn't be any gradients, the light wouldn't go bend upwards towards that medium, because it would be through one equal density layer all the way.
No,
so it wouldn't have that bending.
No, because the light always reaches the observer. It would just bend down. So if you've got an object that's 300 feet high and it's a couple of miles away and you're an observer at 6 feet, the light to get to your eyeball would have to, without a shadow of a doubt, travel downwards through the mediums to reach your eyeball.
What about the light going upwards?
Well, it would never reach your eyeball then, would it? But we have vision, we can see things.
This is why I made this, because I'm standing at 22 meters, and the top of that turbine is 300 meters, so you can't just bend, so this is sinking.
Okay, so you say that it just can't be sinking. What makes
How would that work, even if the Earth was flat? Because you wouldn't. That would be the same density layer all over. Do you see my cursor here, by the way?
Okay, so can you give me some information about? I mean, obviously you've done a lot of research in this. I mean, you did this over a year ago, and it's.
So at this point, I think Ranty doesn't want to talk about sinking anymore, because I think he knows I'm onto him. Since this was broadcasted, I have been back to the end of the world one more time and made one more observation. So now I have 4 observations from 4 different times of the year, with 4 totally different conditions. Let's have a look. The first time I was there, it was March 10th, 2019. And as you see, that day there was snow on the ground, so this was late winter, early spring. And on that day, with those conditions, all the turbines were well below my eye level, which is still just above that white part here. So all turbines below eye level in cold weather. Next time was just 1 week later, and still it was well below my eye level. It wasn't much difference in the weather, probably a bit warmer, but not by much. The third time I was there, middle of the summer, July 16th, 2019. You see people are here in shorts and swimwear, out bathing. So this time it was warm, and still all the turbines were about at the exact same place, well below my eye level. I was there one time, 4th of December last year, but then it was just too hazy, so that was a bummer. But yeah, I can't predict anything from 3 hours of driving away. So, and as you saw last time I was here, October 18th, just a few days ago. Now it's late autumn, and I think the water is probably warmer than the air. And still all the turbines back here are well below my eye level. There is really nothing much of a change in any of these. They are still well below here. For this to fit my observation, the light would have to bend from the top of that turbine to my eyes, below my eye level here. It would bend a little something like this. So from the top of that turbine, well below my eye level at the lighthouse, and then up again to my eyes. Okay, this just hit me during editing. As I said, the light has to bend down here, down to my where I see the top of the turbines at the lighthouse, and then up again to my eyes. The density gradient is from the gray here. You can probably see the stripes here up to the white part at the top. But if the light is bending down here, why and how is it bending back up again here? Why not the other way around if the temperature and humidity and all that was different? Then I would be watching the top of the turbines here and then bending down again here or whatever. The more I see this, the less sense it makes. How and why does it bend up again from that point to my eyes? That's a few kilometers there.
Interesting.
If this is how bending works, if this is reality, Ranty should have at least 2 Nobel Prizes. Another thing, I am standing here and my eye level is here. And I see the top of the turbines down here. So even that angle doesn't work on a flat earth, because I should be staring right into the water here. For this to fit anything like what I have here below my eye level, you have to take the turbine and the hill and everything and squeeze it together like that. And Windows Paint can't even draw this because it's too thick of a blur here. But here I should have the turbines squished together like a pyramid with the blades looking like distorted something. There would be distortions, no questions about it. Let's try one last thing. I placed all my observations in Photoshop Elements and I laid them on top of each other in layers. All these are shot with 400mm zoom. I'm standing at the same place and the lighthouse is at the same place. So by switching off layer after layer, the turbines really doesn't move anywhere. Of course there are some minor differences. Refraction is a thing. But at no place are these turbines reaching above my eye level. Not even close. If we throw a bit of Hitchens' razor in there, what's asserted without evidence can be denied without evidence. I'd say if you don't have any numbers or mathematics or anything to show for that sinking effect, no weather conditions or anything required, I think my observations show that there is no sinking, because on at least one of those conditions the turbines would be above my eye level. It isn't. On every single one of them they are well below and almost exactly the same all the time. So Ranty, if you're watching this, please dig up some more numbers or a better explanation for what sinking is. We need something more a bit solid. Thank you so much for watching, everybody. See you next time. Bye bye.